Hi, I'm Peter Hawley, President and CEO of Fabled Copper Corp. And today I'd like to tell you about the geology and structural survey on the Bronson property. The Muskwa project is comprised of the Neil property, the Toro property, and the Bronson property, all located in northern British Columbia. We have started reporting on the Bronson property with the various surveys conducted on the Book 6 copper occurrence. And now the bigger picture, the geology and structural interpretation of the Bronson property. Now let's talk about the Bronson property geology and structures and the main three stratigraphic units that underlie the Bronson property. And this includes the Paleoproterozoic Eta and Gatian formations and the Ordovician Kicha group. Diabase units in both the Eta and Gatian formations, but were not observed in the Kicha group. The Eta formation consists of interbedded dolostone and limestones, shales, and sandstones, whereas the Gatian formation consists of dark gray to olive gray pyritic non-calcareous shales with subordinate sandstones and siltstones. The Kicha group occurs as a small window in the northeast corner of the claim block, consisting of massive limestone and calcareous quartz sandstones. The stratigraphy is broad, north-northwest trending, and moderately to generally dipping southwest throughout the property. No macro scale folding is observed from satellite imagery or in historical geological maps or interpretations. Younger thrust faulting of the Eta formation over the Gatian formation occurs in the southeast portion of the property. Additionally, the Gatian thrust is interpreted to occur between the Eta formation and the Kicha group in the northeastern corner of the Bronson property. Three main orientations of lineaments and later brittle faults are also observed across the property, including the first order north-northwest lineaments and the second order, the ubiquitous northeast and less well-developed northwest lineaments. These are suggested to represent kinematic-related fault sets that are associated with copper and cobalt mineralization present across the Bronson property. The Bronson property is unique in the area due to the high proportion of diabase emplacement. Importantly, diabase dike intensity appears to be coincident with magnetic anomalies highs in property scale aeromagnetic survey data. And as you can see, two main types of diabase appear to be present within the Bronson formation property. Number one, an older, more widespread, predominantly north to north-northwest suite characterized by generally narrow and more contiguous, with respect to strike length, diabase units. Suite 1 diabase units show significant deformation and offsetting caused by overprinting by the northeast and the east-northeast trending faults, and an overprinting north-northeast, east-northeast trending suite that is spatially restricted to the central portion of the Bronson property and is characterized by large, strongly deformed bodies of diabase. This suite of diabase is restricted to a well-developed, ductile, brittle, northeast, east-northeast trending deformation corridor, approximately 3.5 kilometers in length and up to 700 meters in width. And this generation of diabase dikes does not occur outside of the deformation zone. Two suites of diabase dikes were also observed during regional evaluations of diabase densities and geometries. And importantly, the orientation of the east-northeast trending Suite 2 diabase units in the central portion of the Bronson claim blocks is parallel to the economically mineralized veins hosting the Magnum deposit. Notice a photo of boudinage, diabase dikes with northeast, east, west to east cross-cutting faults I took while I was in the field last summer. Copper mineralization occurs as quartz carbonate and chalcopyrite veins in close approximation to both Suite 1 and Suite 2 diabase units. Vein orientations are also characterized by both north-northwest and northeast trending geometrics, suggesting a structural component to a diabase emplacement of kinetics. Integration of geophysical and geological data indicates that a larger scale transtensional fault system may control the deposition of both diabase and mineralization. North trending, or first order, bounding structures are located on the east and west of the property and likely form early in the transtensional structure setting. Diabase Suite 1 was in place during the stage deformation. As extension progressed, second order and internal Northeast trending, brittle or ductile, and brittle structures formed and facilitated the emplacement of larger bodies of diabase suite 2. Structural interpretation of the Bronson property mineralization appears controlled by a north to northwest trending sinistral transtensional shear zone with interior east and northeast trending structures, potentially acting as zones of dilatancy and thus copper precipitation. Now, going forwards, using the results of the data gathered by the geology and the structural surveys and the kinetics of the movement related to emplacement of diabase dikes and related mineralization, this will be closely examined, but not only on the Bronson property, but on the Neal property, where the same overprint is seen. The northeast and east-northeast trending zones of transtensional deformation may represent fertile zones of copper-cobalt mineralization and should be mapped and sampled in detail to better understand the three-dimension geometry. Follow us while we explore for fabled green copper in northern British Columbia.